What have you guys been thinking critically about today?
How to maximize gains at the gym.
Okay. Any confirmation of mass attracts mass at the gym?
I have no evidence of mass attracting mass at the gym. All the weights would be touching each other then.
Well, next time, rent a gravimeter, bring it to the gym, and put more more mass underneath it. See what happens.
Where can I get a gravimeter at?
You can rent one at a construction rental, but that's the more sophisticated rental places for oil industry and stuff like that.
Wait, and it measures gravity?
No, it measures acceleration.
Due to gravity?
I don't know, due to what? Due to the mass being placed underneath.
So if I was to increase my elevation above the surface, like if I take a reading or like if I place it on the ground and then I move it up, it should read more acceleration because there's more mass of gas underneath it, right?
Well, you'll have to find out.
Wait, nobody's done it yet?
People have, but we don't look at what other people do.
Well, I'm just curious what the readings have been so far. I mean, I don't have a gravimeter to be able to say that they would or would not read more or less.
Let's think critically what the prediction of the statement mass attracts mass would be, right?
Okay.
So I like it that you said the mass of the gases, right? Well, let's say the
Sure.
gravimeter is resting on the ground.
Mm-hmm.
Would the mass of all the air above it attract it upwards?
Yeah, there should be some pull, yeah. If mass attracting mass is true, yeah.
Good critical thinking so far. So the resulting vector of acceleration that the gravimeter measures, that's the only thing it measures, would be the mass below attracting it downwards and the mass above attracting it upwards, right?
Sure.
So is it measuring mass?
In some sense, yeah. So then it's actually a gravimeter is just a fancy spring scales. I mean, some of them are electromagnetic and they suspend objects in electromagnetic fields, the super precise ones. But in the end, it's the equivalent of a spring scale. So,
Well, hold on. Does it measure mass in free fall, like in zero gravity?
I don't think so. I didn't say gravity, so I'm not worried about gravity right now or free fall. Just saying that that's what it measures. So then, if the mass of the gas is above is pulling it up, and the mass of, let's say, the Earth is pulling it down, then when we elevate that gravimeter, there will be more stuff below than there was before.
Yeah. So it would read. So that's what you're saying. It would read. Would there be more mass being pulled down?
Let's think critically. We also know that the change in the rate of acceleration that gravimeter measures is a function of two things. One, the mass. Two, the square of the distance from that mass. So now the question becomes, is the addition of the air, the mass of air below, does that have greater impact than the increase in the distance from the mass in the ground? If the mass, I would propose that if the mass in the ground is much greater, then the increase in distance will result in a decrease in acceleration, even though there's more air mass it will just overpower that. That'd be my guess.
So even though there's more mass, there's less acceleration from mass attracting mass, is what you're saying.
Yes, because it's a function of mass and the square of a distance. So a big impact, right?
Wait, I thought you said mass attracts mass. So if there's more mass, why would there be less acceleration?
Right. So mass attracts mass is the correct statement would be mass attracts mass inversely proportional to the square of the distance between the masses.
I'd like to do
It's
this
just
in
a
free
mouthful
fall
to say
so that
it.
you can set up a controlled environment.
Yeah, you should totally do that.
Wait, I could do this.
See how easy it
Yeah.
is to think critically?
First thing, if I did this with like an empty propane tank, I could place it underneath your gravimeter. I could pressurize the tank with more gas, and it would create more acceleration in the gravimeter. Is what you're saying?
Absolutely. Yes, absolutely.
Like, can you show me where this has been done?
Absolutely not.
Okay. Okay. So this is all just based off of like the
Critical thinking.
presupposition that mass
Yeah.
attracting mass is true.
Well, that we know. Who is snoring, you guys?
Yeah, I'm gonna save him the embarrassment. I'm just gonna mute him. Hey, Midnight, if you actually are there, just type in the side chat, bro. I'll mute you. Looking knocked out. Yeah, I mean, I would like to see this validated somewhere if possible. When I know you're just saying like, if this is true, then this would happen. It's like if I was to say if
Yeah.
Superman was real and he was to fly in the opposite direction of the Earth's rotation, then he could hypothetically reverse the spin of the Earth in the opposite direction. Presupposing Superman in the first instance.
Well, that's just because you don't know what I know, but that's yes.
Yeah, but would Superman actually make time go backwards, or would he just make the Earth spin backwards but time progress?
Presupposing Superman's real, I would say that maybe if you could spin the Earth in the opposite direction faster than the speed of light, maybe. Well, I wonder if Santa Claus could do the same thing actually, considering the speed that he'd have to be moving to travel to each house on Earth in the span of one night. I could probably do it too.
Yo.
Archangel, can you turn your camera off, please? It limits the room, dude. You know this. Thank you.
How does he do that every time? Weird, like he just wants to be seen. Anyway, what's up, Pantheos? How you doing, bro?
I'm doing alright. How you doing?
Chilling, bro.
Yeah, I was on here like an hour ago. Well, I don't know who it was. Someone sent me these videos of, you know, that Red Bull guy, the guy that jumped off 28,000 feet.
28,000?
Yeah.
I think it was 100.
Sorry?
I think it might have been over 100,000 feet.
100,000 feet.
Yeah,
Was
it
that
was over.
28,000?
No, that's lower than a commercial aircraft.
All right, now, hang on a minute. So you're assuming it's 100,000. That's like how many miles is that? Like that's like a lot, right? That's like 100 miles or something.
I'm not sure of the exact number. Let me get it for you.
What do you see like when you're 100,000 feet in the air? What do you see? Do you see like what do you see? Flat or curvature? What is it?
So I've never been there.
It was
Hmm?
128,000 feet.
Yeah, because I mean I watched it. I did. That guy Felix, and then some other guy sent me Neil deGrasse video saying that it's flat, something like that. I mean I didn't know what it was on about, but yeah, I watched it. I analyzed it, but it's a curvature, bruv. It's a curvature. I mean, like, I watched it, and I'm pretty sure there's a curvature there. I'm just saying, you know. I mean, like I watched it 2 times.
Which
I saw a
camera?
curvature.
Which camera?
It was the GoPro, you know. Do you remember that one? You know, the Red Bull one, when the man
Yeah,
jumped out the
I know what
plane?
you're talking about. I'm just talking about which camera view are you talking about? You're talking about the one with the GoPro, right? What about the one that's inside
Yeah.
the capsule? The camera from inside the capsule shows a flat horizon, but the GoPro shows a curved horizon. So which one's true?
I mean, well, there's a couple of them, isn't there? Like, how many cameras were there? Like 2 or 3 of them? I mean,
At the moment, I'm just pointing out that we've got a stark difference with 2 cameras. One on the gondola, one outside the gondola, showing 2 different horizons, one flat, one curved. Now, if somebody sent you the video of Neil deGrasse Tyson, you turn around, I ain't got a clue what he was talking about. He was talking about being as high as the International Space Station and Felix Baumgartner and what you would perceive of the curvature of the Earth. He isn't high enough to perceive that amount of curvature that was seen in the GoPro camera. That's what he was on about.
yeah. It was that. Yeah, but I mean, he never said it was flat, did he? I mean, there was a 20-second short YouTube video mentioning it was,
I'll go and get the video. He
but
said, that stuff is flat, to quote him
all right.
directly.
All right, can you put it up? All right, let me. Okay, so I remember seeing that as well. It was a 20-second video of him saying that, but I think there's more content to it.
Sorry, so you do remember him saying that stuff is flat then? Do you bang your head
Yeah, but I mean,
against
but on lower altitudes, you see it as flat, but the higher you get, it curves. I'm
Yeah,
pretty sure I said
exactly.
that.
He was talking about Felix Baumgartner's jump, specifically that instant, saying that he shouldn't been able to have seen the curvature from that altitude. He has to be higher, if not further, than the International Space Station, because he's only perceiving about 3% of the surface of the Earth. From that vantage point, that stuff is flat. So just to put everything into context for you, mate.
Yeah, all right. Okay, I know where you're getting at here, right? But
Good.
look, I mean, I listen to Neil deGrasse Tyson a lot, right? I listen to a lot. I mean, it's quite complicated, the stuff that he says. I'm not like a scientist or anything, but he said from a high altitude, you don't see the curvature with your naked eye. That's what he said, right?
Mm-hmm.
And, you know, our perception is limited, isn't it? Human perception with limited altitude,
That's
it
why we get
doesn't mean a
a
curvature is
camera with
effective,
a wider
right?
angle of view. You brought it up, dude. It's the
But,
GoPro camera. You must understand that
yeah,
if you want to get a wider angle of view, you're going to curve horizontal lines, which is what a GoPro does. You know this.
yeah.
Yeah.
Exactly.
So
Like, look,
this is
the
why
fisheye thing, right? Yeah.
This is why I brought up the different cameras. The one inside the gondola shows a horizontal flat horizon, but the GoPro camera shows a curved horizon. So just in that instance, dude, which one's true? The flat one or the curved one?
The GoPro one. I mean, I'm gonna have to go for the
The one
GoPro
that
one.
curves horizontal lines, so you get a wider field of view.
Well,
So,
yeah, I mean, yeah, I did. Which one's the other one? The gondola, you said?
it's like, dude, I'm trying to lay this down logically, and now you're coming to these conclusions. It's fucking, I don't know. You've got Neil deGrasse Tyson telling you that you shouldn't see, Felix Baumgartner wouldn't be able to perceive the curvature of the Earth. I've given you two camera angles from the same fucking thing that shows a horizontal line and a curved line. We understand that GoPro cameras curve horizontal lines, and you're still spluttering. What?
Yeah, but have you got a video of the other one? Not the GoPro one, but the other one. Have you got? Which one is it? Did you put it on the side chat?
I'll go and find it for you. Okay.
All right, no rush, Jedi. No rush. No, but I'm a truth seeker, bro. I mean, I'm looking for the truth,
Really?
man.
Really? I've just pointed
I
out a
am.
contradiction to you, and it should leave you in a conclusion, well, you don't know then. Because you're already
Yeah.
relying on other sources, and the other sources are contradicting themselves. Right, Truth Seeker?
If you
Well,
can't see
yeah. I mean, look,
curvature from
I don't
24
know who
miles
to
up,
trust
dude.
anymore.
If you can't see curvature from 24 miles up, what makes anyone think that they see curvature at the beach or from an airplane and so on and so forth?
Yeah, I mean, you can't see it from the beach because our perception is limited, isn't it? Like, we obviously can't see it. Our eyes are not that. I mean, we're not psychics, are we? I mean, yeah, we can't see that, can we? Yeah.
Not
Right. So
psychic.
what evidence do people have to believe in a globe in the first place if nobody's ever seen any evidence of curvature for like
I
all of
mean, there's
human
people that.
history?
Do you believe that Neil Armstrong went to the moon?
Why are you asking a different question, dude? That's a different
A simple
question.
question. But, I mean, okay, but what I'm trying to say, the higher you go, I mean, the more obvious it is, isn't it?
How
Is it?
24 miles is still not obvious enough, is it?
No, that's obvious. I mean, yeah, if you're gonna go eight, I mean, I'm pretty sure Felix did see the curvature. I mean, like, he was high, you know, like he was really not as high as I am right now, but he was high.
Sorry, when you say he saw the curvature, what, with his own eyes, or the curvature that we see with the GoPro camera, or the horizon that we see with the other vantage point from the gondola inside the capsule? What do you mean with
Well, I
his
don't
own
want to
eyes?
go. I mean, yeah, I don't want to go circular, but I'm pretty sure with his own eyes, he did see the curvature because he was 18,000 feet in the air, wasn't he?
Yeah, but Neil deGrasse Tyson would tell us that from that altitude, that stuff is flat with our own perception.
Yeah, but you did mention that. I watched the video myself. I did, but I mean, was that the whole content? Have you got like a full video of it? Because I mean, pretty sure that was just cut off from somewhere. I mean,
No.
very briefly.
He said, I quote, "You don't see the curvature of the earth. That stuff is flat."
From a low altitude, yeah.
From Felix
Obviously, it looks flat.
No.
Baumgartner. That's what he's referencing, Felix Baumgartner. That's why he's talking about the curvature of the Earth. From that altitude, my God.
Are you sure he wasn't being sarcastic?
Yeah.
I mean, look,
He was
think about it, Jedi. I mean, like, it might have been sarcastic. I mean, like,
science
No.
communicator. The science communicator who's trying to communicate science, just so everybody is clear, he was going to use sarcasm. He's American. Don't get
Yeah,
sarcasm,
he
so well,
wasn't sarcastic at all. Listen, when you actually work out the geometry of what the earth should be if it's a globe and how much curvature should be present and available to your eyes from all different heights, including 24 miles, you arrive at the same conclusion that there's not enough. If Earth is a globe, there shouldn't be enough curvature for your eyes to perceive, period.
yeah. Oh, yeah, okay, I agree up to a certain amount, but I mean, Neil deGrasse, he did also mention that, you know, satellites only work on a curved Earth and stuff like that. You know, like the globe, what the globe people say. You know, I've seen his I need to look into it, which one it is, but I'm pretty sure in some of his podcasts he did mention that the
Yeah,
Earth
of
is
course. We're not saying he's a flat earther.
We're using him as a hostile
exactly.
witness.
Yeah, he's not a flat Earther. Yeah, he's not. Yeah, he definitely is not a flat Earther. Yeah.
In this instance, we're using him as a hostile witness. He says, who's a science communicator, he believes the Earth is a ball. From the altitude of Felix Baumgartner, that stuff is flat. That's a globe earther, science communicator. A hostile witness in this point. Somebody on your side who tells you what to believe.
I need more evidence, my G. I need more evidence. I need to look into it more. I need more evidence. It's the math isn't working out, bruv. I'm trying my best, but I swear I'm trying my best. It's not working out.
What math?
Don't you believe in mathematics now?
No, I'm asking you what math isn't working out.
Because the higher you go,
Yeah,
the more it curves.
you're saying it's not working out. Now you're telling me how it would work. What math
Well,
isn't working out? It's what you said. The math ain't
I'm
working
just
out.
saying to you, my G. I'm just saying to you, right? The higher you go, your perception opens. It's like you go up and you see people like ants, don't you? The more high you go, the more small things become down. So then the Earth curves. It does, and you go
Yeah.
into space.
Pantheos, I just posted in the chat the math. I worked it out on a spreadsheet.
What is that? All right, let me check it out. All right, what is it?
Yeah.
What is
So
all?
from
Okay, so okay.
yeah, I'll show you the formula. So from 25 miles high, you are seeing 0.3% of the surface of the Earth. Would you expect to see curvature when you're only seeing 0.3% of a ball?
No, it's not
No,
possible.
exactly.
No, it got to go higher.
That's how high,
Yeah.
right. So that's how high weather balloons go, and that's how high Felix Baumgartner went.
Which one is it? Is it the weather balloon? 25,000, isn't it?
Yeah.
Real quick, you guys, are we treating this guy seriously? It's Friday night there
What about the
in Britain.
satellite? Look, you mentioned
He's just saying random shit.
you mentioned the satellite as well on the chart, right? There's a satellite. So you believe in satellites as well? You believe that satellites can go that high then, right? Higher than the balloon?
Maybe
Because
they
I see a
do.
satellite there.
Well,
You
yeah.
see-
I mean, I take their claim of what satellites do, and I plug in the math.
I thought you didn't believe in satellites. I thought you
Do
said
you
it didn't go to
understand that
space.
I'm testing their claims?
Yeah, but you put it in your chart, right?
Yeah,
Okay,
so
so
I'm
when we go
testing
to
the
the
claim.
satellite, so all right, Master, when we go to the satellite, can we see the curvature then? What do you see in that then? 40,000. What do you see then? Oh no, 400,000. Sorry.
Well, it depends on the satellite at that height. I don't know if anybody's got any footage from that height, but if you are at that height, that's how much curvature of the Earth, if it's a globe, should be present to your available site.
Bingo. And I'm pretty sure people have gone that high.
Really, what in the satellite?
People.
What the fuck? Who's gone that high, dude? You're talking about people who went to the moon?
I told you, bro. Neil Armstrong.
Neil Armstrong. Okay.
Yeah, in the 60s. Yeah.
How did they know how high the moon is?
Oh, the thing, light speed, takes about, 8 seconds it does, doesn't it, for Earth to go to the moon,
Yeah.
doesn't it? The laser
No, it
test.
doesn't.
No,
Okay.
no, that's the
Well,
I'm
start.
telling you
how
guys,
long does
this
it
guy
take
is
this?
drunk and he's just trolling.
I'm not Peter. I'm not drunk. Don't drink. I've been sober for about 5 years now.
Yeah, 5 minutes maybe.
Except for weekend.
No, man, I'm serious, bro. I'm sober, bro. I'm serious, man.
This is you not being drunk, then fuck.
Yeah, that doesn't help
Oh,
you.
Jedi.
It doesn't help your case.
Yeah, do yourself a favor and stay
man.
sober then.
I mean, all jokes aside, right? I mean, look, I believe in the moon landing and stuff like that. I mean, I come on, man.
Oh, you're
I
a
can't deny
patriotic American.
Patriotic American.
Go Trump, right? Moon landing.
First of all, the moon has nothing to do with the shape of the Earth, so why do you even bring that up?
Right, Peter, let me ask you a question then. How long does it take for the sun to hit the Earth?
Like crash into it?
Like The prediction is
It
5 billion years, I think is the prediction.
takes 5 billion years for sunlight to hit Earth.
Oh, sunlight.
No, you said the sun. Like the prediction is that the sun will expand. The global prediction is the sun will expand and engulf the Earth. I think I might be guessing, but around 5 billion years from now.
Yeah. I mean, yeah. I think. I mean, yeah. So you're a psychic. You can see the future. Yeah. All right. So yeah. All right. But I mean, like the sunlight. I mean, like how long does it take for the sunlight to hit Earth?
8 minutes. I'm educating you on your own model. 8 minutes.
Great. So if I get like a big laser and if I push it towards the moon, how long will it take for it to hit the moon?
1.3 seconds.
Oh, that's how long. That's how you find the distance to it, right, Peter?
Yes, I'm not in disagreement with that. You just said it's like 8 seconds or something. You don't even know your own model. So this here is an advanced flat Earth discussion server. So when you come here, you gotta at least know your own model. And still, you're not gonna prove the globe, but you need to know your own model at least. You're nice and sussed up, Gov. So you're just not in the position to have a serious conversation, especially with people like Jedi.
Okay, Mr. Smarty Pants. I apologise for getting a few seconds off. Not to be sarcastic with me. You're so smart, you know everything, don't you, Peter?
I mean, a few seconds, you overestimated it by a factor of 8.
I gave an average approximate. I gave an approximately. I didn't know it off by heart, right?
All right.
I
Your thinking
man.
was
People
in the
like
right
you, bro. I
place.
swear, bro.
They use
You think you
time.
know everything, bro.
Again, this is an advanced server.
Oh, come
Advanced
on, bro. What's
community.
wrong with you,
This is
man?
not like
So cringy, bro.
Earth Shape 101, learn the basics. This is, you got serious argument,
Oh,
let's go. Otherwise, just sit there
such a
and listen.
nerd, bro. I swear, man.
Yes,
Dude.
I am a Shape of the Earth nerd, yes.
It's so
The
much
thing
fun.
about
And Peter, it warms my heart that you get it finally. Welcome to Flat Earth.
I've always been here.
That's right. We've
Well, you
all
found your
always been
community.
here.
Enjoy.
You've been here too, Pantheos. You've been here on Flat Earth the whole time.
I have. I'm even in the server myself. I listen to you guys a lot. But maybe I got a few seconds mixed up. I apologize for that, Peter. Please forgive me. I know you know everything. I know you're so smart. Yes, please forgive me. But
Do you
people
listen to us
make
a lot?
mistakes.
You're forgiven. You're forgiven.
You do realize that, don't you?
Do you listen to us a lot?
Yeah.
Okay.
Yeah,
So
every now and then. Yeah, I go. Yeah, I go.
okay.
Yeah.
So why do we say the Earth is flat?
I mean, I don't know, Jedi. You come up with all sorts of stuff, man. I mean, one day you say this, and one day you say that. I mean, a bit all over the place. I'm not here to mix
Okay.
the soup. Don't
Oh,
get me wrong,
gosh.
right? But
Who's your favorite Flat Earther?
my favorite flat earther.
Yeah, do you have
All
a
of you
favorite?
guys. All of you guys. I love you all.
Okay, well, who's the most annoying Flat Earther? How about that?
Oh, the most annoying one. I'm gonna have to go
Yeah.
for. Let's see. I think Peter. Yeah, I'm gonna have to go for Peter.
Oh,
Yeah.
Peter, I'm sorry.
Yeah. He's the annoying one
Okay, I
because he's
take it as a
Mr.
compliment.
Smarty
Bullshit
Pants. He
is
thinks he knows everything. Yeah.
Well, think about it. I'm annoying because I'm triggering his cognitive dissonance, so I take that as a compliment.
Oh, are you a psychologist now? Oh, you must be so smart. Can you please give me a therapy lesson? Come on, bruv. I ain't got money to go to a
lesson.
therapist.
I'm
Please,
happy
you're
Can you
to
so
do it.
string the
smart.
right amount?
Yeah.
Can you string the right words in context to form a conductive sentence? You just seem to pick random words and cobble them together. Therapy.
I
I'll give
can.
you a therapy.
Lesson.
I'll give you a therapy session for free in 15 seconds, which is less than it took you to ask me to give you the therapy session. So here it comes.
But what?
Just can you shush it for 50? I promise to time box it to
Yeah,
15
go on.
seconds. So just put a stopwatch on, and I'll tell you when to click it. Click it now. Here it comes. Go outside, look around. The Earth is flat. You observe it as flat. Deal with it. Actually, it was less than 15 seconds.
Thank you for that. But what you're doing right now isn't evaluating evidence, it's confirmation bias. You've already decided the
Good. We
conclusion.
evaluated all
You're
the evidence with
reinterpreting everything
people
to fit
way
it.
more
Yes.
knowledgeable than you on the topic. So we're just telling you what we already know, and take it or leave it. If you want to confront us on it, be precise, be to the point. Don't just say, ooh, maths doesn't add up. Dude asks you, what maths? Well, it shouldn't be that way. Okay, what maths? I don't know. Yeah, that's your argument.
I wouldn't say that's my argument, but your belief isn't being challenged. Your
No,
identity
but that's
is,
how
and
you
that's why you're
sound.
defending
Like
an
I'm giving you
interpretation instead
feedback
of a
from the
quote.
audience. That's how you sound. It sounds like this. Maths doesn't add up. Okay, show us. Well, it shouldn't be. I don't think it works that way. That's your argument. Bro asked
I
you
didn't
to
even
show
give a
the
full
math.
argument.
You didn't. You just said, well, I thought about it, and something doesn't add up.
Hey, Peter,
Okay,
got a
show me
question
which.
for you. Does math attract math?
Yes, it does. That's math actually generates more math. So in some sense, math
Damn straight.
attracts math.
Math attracts math.
You're Stark, mic up, bruv. I want to have a little chat with Stark. And I was gone all quiet.
Seriously, no offense, bro, but you're a little bit of a waste of time, not because we're hating on you, but because you come in here with actually you don't even have the basics about your own model. What can we tell you? Like, you're gonna have these very high level responses, like, oh, it doesn't make sense. We're beyond that level. Okay, so no offense.
What are you? Are you God or
You're in the
something?
wrong
What do you
league,
mean,
right?
Peter? What are you on
You're in
about?
the Premier. I'll explain it to you. You're in Premier League. You should be in that. What is that? There's Division 1, Division 2, Division 3. Then you guys have some kind of local, amateur clubs. That's the level you're in, and it's actually it's good, right? Those guys can play soccer or football, as you would say it, but they cannot show up and face Arsenal, right? So just that's the way it is. Don't worry about it. You're still a good player.
Yeah, but when
Just go play
when
somewhere
you
else.
start to status shame, right? The thing is, Peter, when you start status shaming, it means that you've run out of content, and your belief is under cognitive
But I'm
threat. So your
basing it on your
ego,
performance. This is I have assessed your performance, and unfortunately, you're not the only one. We get baby glurfs here every 5 minutes. They come in
yeah, but
and
I
they're
mean,
like,
what's your
"Oh, it's a
major
globe."
anyway? I mean, what have you studied, Peter? Like, what's your major? Like, what are you anyway? Are you? And I know you're delusional, yeah, but I mean, what are you supposed to be exactly? Like, are you? What did you study? What's your major? Tell me that. I'm not going to bully you, I promise.
Okay, but why does that matter?
It does matter because the way that you're speaking is very horrible. It's not normal. That's why there's something wrong with you.
And my major, that's just me being an asshole. How does that my major,
Well, I know
relate to
you're an
that?
arsehole, yes. But the thing is, you don't know how to have a conversation. That's your problem. You don't know me. I don't know you. Like, what's your issue?
This is the internet, man. It's nobody knows anybody. This is all just random people, and here at least
It is. I agree with you, but calling me low level isn't a rebuttal. It's avoidance strategy. Because when
No, you
reasoning
are low
fails, your
level. I've been
ego
listening.
reaches for hierarchy.
I've been
So
listening
You
to
are a
you.
low
drop the
life.
evidence of the Earth
Yeah.
into the side chat, and we'll discuss.
I mean, there are
That
other
way we
Globers
can
that come
get
in
off of
here
the.
that perform much better than you and in a more engaging way and actually engage on more facts, and we still don't
Got
believe
no
they're
emotions,
correct. But
Peter. That's just it. You've got no emotions. Like,
you're just bored,
yeah, I mean,
Joel.
you're horrible. You're a horrible person.
Okay.
Okay.
Thank you.
Evidence of the Earth, please. Thanks. What is your claim?
Not at the moment. I'm just listening in at the moment.
Well, I'm listening to you cry, and I would like to get back on topic because you don't
All
want to
right,
talk
yeah, let's
about
get
that
back on
all.
topic.
Because
Yeah.
apparently, talking about people and their emotions is, proof that you don't have content. Please, you're here to help us make content. What is your evidence of the Earth?
My claim is simple, all right? I mean, I came an hour ago, mentioned it before Peter tried to put me down, right? Gravity, all right? Because, look, I just want to know more about it. I want to know your perspective as well. I come in peace. But people like Peter tried to put me down, right? He's a lowlife. Anyway, look, my claim is very simple, right? Gravity it's a theory, it is, yeah, but at least it's measured, it's repeatable, and in my opinion, it's our best current explanation that
Okay.
mass energy curve space time, right? I mean, you don't have to like the explanation, but the predictions work.
All right. So, does gravity cause things to be flat or sphere?
I mean, sphere. Yeah,
Okay.
sphere. Yeah,
All right.
gravity.
So,
Yeah,
water is
Hold
on
on.
the
Can I
Earth.
ask him?
No,
Are you
water's
sure?
on the Earth. Hang
No, no,
on.
no. Don't
Water
worry
is on the
about
Earth.
water.
I'm going to let him have his gravity. I don't care to argue about the gravity, right? You have gravity.
But he's
You
wrong
have a
about his
sphere.
own
You
model.
have water on the sphere. Now the water's causing, or the gravity is causing the water to actually conform to the shape of the sphere. Now, can you tell me how to measure the curvature of the Earth?
I mean, I personally don't know how to measure it myself. I've never measured it myself, but I mean, according to like my research and what I know, like when you look at like huge celestial objects like the moon or something, they're all spherical, even though no one's actually touched it, according to you. But you measure the Earth by measuring how the horizon, how it drops with distance. So the higher you go, that's why I was mentioning about that Red Bull guy, Felix, before, right? The higher you go, the more you see. I mean, I don't know the specific measurements. I mean, yeah, Peter did have a go at me.
I hear you came back after watching those videos, and I'm the one who brought up Felix. It's
There
flat,
we go. How you doing, bro? Nice to
it's
see you, man.
flat,
Yeah.
like Neil deGrasse Tyson said. It's flat, didn't he?
Yeah, I
Didn't
watched it, Professor.
Yes,
Look, I
he
watched
did.
it. I watched it.
Welcome to Flat Earth. You're the new Flat Earther. Remember, you said if we give you the videos, you'll go watch them and be a Flat Earther.
Yes, I watched it, but I'm still skeptical. Triangle, look, I'm still skeptical. I am. Like, I mean, I did watch the video and all that, but I mean, I'm just saying, like, um, stars, right? For example, stars, right? They shift the position depending on the latitude or the longitude, whatever, at the season, right? It only works from curved Earth. It does, and yeah, that
No,
means
that
yeah.
only
I
works
mean,
from a flat surface. Yeah, you can only measure that from a flat surface. You actually can't take any angles from a curved surface. So whoever told you could needs their teaching license taken away.
I mean, okay, this is just my education, I guess. I mean, maybe I'm not on like your level, like or Peter's level, let's say, the very smart person, the Peter that knows everything. Maybe I'm not on his level, but I mean, I believe that your statement is actually false because you can measure angles on
All
curved
right. So
surfaces. That's
then,
how geometric it is. Yeah.
please describe the method that you would take in order to get an angle measurement to a light in the sky.
Well, I mean, I can't just get a ruler and do it. I mean,
No,
you
you
measure the
wouldn't
curvature.
measure angles to a light in the sky. That you're right. You wouldn't do that.
Yeah, you use a stick, like
What?
not like a literal stick. Like use a thing. How do you pronounce it?
Oh,
Gnomon. A
I have a
gnomon.
stick.
Yeah.
Oh, what? What do I do with the stick to get an angle measurement to the light in the sky?
All right. So you measure the sun's angle. All right. At the same
I
time
thought
of
we
the
were talking
day.
about color. Okay.
Sorry.
I thought we was talking about stars. Okay, so I have a stick. I have the sun in the sky. What do I do now?
All right, great. So now you got the stick, and so I'm gonna go step by step, right? Two sticks, all right, at the same length. The sticks are gonna be the same length, all right. So
Right.
you level the ground surface, the
Oh
north
fuck!
and the south.
I thought you said I didn't need a flat Earth. Why am I having to level the ground now?
You have to level the ground, you do, because it needs to be like the same length. Like the two sticks need to be like the same length, all right?
This
So
sounds
you
exactly
tape
what Mr. Triangle was talking about. How you need a flat Earth, and you're like, no, you don't need a flat Earth. You just need to level it.
well, I mean, yes, you need to level. Yes, you need to level it out. You need to ground it. Like put two. Like just imagine, right? Two. Have you got two sticks?
I don't have
We
two
go
sticks.
step by step. Okay, just imagine it. Like just close your eyes, right? Close your eyes and
Close my
listen,
eyes.
right?
Follow.
Right. So you get two sticks, broom
Right?
handles, and they need to be the same length. And you ground the
Okay.
surface at each location. You get a tape measure, right? You for
Yeah.
stick height and for the shadow length. And then you need to have a friend like somewhere else in like a city, like either north or south, like maybe like 300, 400 miles apart or something. And
Okay.
then you, yeah, you put the stick on the flat ground. You use a plumb line. You know what plumb
There you
line is,
go.
right?
There you go. You're accusing
Yeah.
you're accusing everybody of using a flat Earth again. You cannot use a plumb line on a ball, and you can't make an angle to something in the sky from the surface of a ball. That's why you got to keep flattening everything
Hold
out.
on, why can we not use a plumb
Mm.
line on a hypothetical ball?
Because
It works on any.
you don't have it. Where's the plumb line going to point to, Peter, the smart guy?
Well, in the globe model, to the center of the globe.
No, yeah, but you don't have any center.
All right. He's got a plumb line.
What do
He's
you
made
mean?
a plumb line fall to the ground. Now what? What's next?
Yeah. Okay. But this plumb line it works on any surface. All right. So
All right.
flat, curve, it works on any surface, right? It doesn't care if the ground is flat or curved. It aligns with what does it align with? Tell me.
Right.
Gravity. All right. Yeah.
Okay. Perfect vertical. Now we have vertical. What's next?
Okay. So now so now you got the sticks. So now we got a measure from the thing, the sun, right?
Yeah.
So what we're gonna do at two different locations, your friend let's say is in the north and you're in the south, and you use the stick and you measure the shadow angle relative to vertical. Now, how do you do that? I'm not a scientist, okay? Like this is not my major in this, but I'm sure you have the coordinates for this because I mean I don't know it off by heart. I'm not gonna lie, but I'm sure Peter will know because Peter's really smart. Maybe we can get some advice from Peter. Maybe Peter, could you tell us please the exact maths on this because you know you're so smart.
Yes, I could, and I will. So first of all, you don't need a friend. You could just measure these two locations yourself, 1 year after another, right? Same day of the solar year. Second of all, yes, you put the stick in the ground. I will explain the Eratosthenes argument, right? You put the stick in the ground, you measure the angle of the shadow, and then you draw on a sphere, you draw the relationship between the arc. So the distance between the two cities is the arc length, right, over the sphere. You have the difference in the angles, and from this you calculate the radius. Like there's a
And
cosine
nobody
somewhere
ever
in
did
there.
that. And nobody ever did that.
Sure, sure. So the point is, that's
Peter,
the
I'll just get rid of
Eratosthenes
you.
argument.
I'll just get rid of you when you say sure to me, because
Okay.
nobody's ever done that. You can't go
Okay,
out and do
nobody
it.
has ever
Nobody
done
can
that.
do it.
Nobody has ever done that. But that's the argument. That's the Eratosthenes argument. Now, dude, just to just to show you what I meant earlier. Somebody asked you, does gravity form things into spheres? And you said yes. Can you tell me why in your own cosmology asteroids are not spherical?
Oh well, asteroids are circular. I mean, it depends on the shape. Like some asteroids are circle, some are like weird shapes and stuff like that. But they're not spherical because they don't have enough thing for it, or is it mass? You know, they don't have enough mass for the
Oh, okay,
gravity
okay.
to
All right,
overpower.
all right.
Yeah, yeah,
Okay, okay. Hold
yeah,
on, hold on.
yeah.
Just
Because
step by step. I
yeah.
promise. These are pointed questions. Give me pointed answers. Don't give me your entire manifesto. I know you have a manifesto. Just don't provide it
Yeah, I'm
at
so
any
sorry.
opportunity.
I know you're
All right.
so
Okay.
smart.
Cool.
I'm
Cool.
very
Cool.
sorry. Yes, please carry on, Peter.
So
Yes.
what do you think is the reason? I think you're right. There's not enough mass, but like what's the issue there? Why do we need more mass to form a sphere?
Well, I mean, that's a really good question. Because look, we
I
need more
know.
mass because gravity
Really
is
not.
proportional to mass. Without the mass, gravity is too weak to do anything. You know,
Why?
like
But why is it too
the-
weak? I'm gonna give you a hint. Is there something in its way?
well, I mean, look, low mass is weak gravity, isn't it? So high mass is strong gravity. No
I
mass is
understand.
what? No gravity,
I
right? Yeah,
understand, but
yeah.
like low mass would still generate acceleration in your model and form a sphere. So there has to be, this is a strong hint now, there has to be some other force in the way of gravity in that situation of an asteroid. Yes?
Well, but I mean, yeah, but it's not God, obviously. You know, I mean, even massless
No, it's
particles
not
like
God.
light, like
It's
photon, they change direction in the field. You know, like
yeah.
that's not the same
Okay,
thing as
here's the
gravity.
answer. The electromagnetic interactions between the particles forming the asteroid are strong enough to overcome the gravitational attraction. If the asteroid, I'm explaining your own model to you, if the asteroid is
Oh,
much
about
bigger,
gravity.
then the gravity will overcome those internal structures of the asteroid. So the correct and form a sphere. That's your own model. So now there's actually an equation that tells you how much mass of a rocky object would be required for that to happen. Now, so the correct answer to the question you were asked is sometimes gravity forms spheres and sometimes it doesn't. And it depends on the internal rigidity of the object and its mass. So if I told you that the Earth was flat, but still told you that mass attracts mass, as your own model says, I could then say the internal structure of the Earth can prevent it from forming a sphere. So that's
That
thinking
is
critically right here.
okay, yes, all right, but I mean, I don't know what side you're on because you're giving my model and then you're turning it into like your
That's
own
what
word. I
we
think
do here.
you're doing some psychological manipulation here, right? But I
Well,
won't
first
fall
of
for
all,
that,
I'm
all right?
using this opportunity to teach you your own model because, like many baby glerps that come here, you don't even know it. Secondly, I'm trying to show you where the disagreements are and where they are not. As a flat earther, I'm telling you that the issue of mass attracts mass is not directly related to the shape of the Earth. It's not an automatic win if you said, oh, look, mass attracts mass, boom, we live on a sphere. No, there are more factors here that you would have to rule out and explain to arrive at that conclusion, and so far nobody has.
Well, yeah, look, Peter,
Which is
I know what
why
you're
I
doing,
would
right?
prefer we stick to the topic of curvature so that we can identify whether the Earth is a sphere or not.
Absolutely. Let's just do that. Let's not talk about gravity unless we want to talk about gravity.
All right, exactly. Okay, so since you don't believe in gravity, we can just hop to another topic then because
I
you did a
believe
really
we have
bad way of.
I
gravity
believe
in
in
this
gravity. It has nothing to do with the shape of the Earth.
There's a
So,
difference between saying it's one of the inputs into the shape of the Earth and saying it has nothing to do with the shape of the Earth. It's just some of the forces that cause a mass to accelerate. So it's it's
Okay, sure,
the sum of
sure,
the forces, and it's one of
sure.
the inputs.
In some sense, everything has to do with everything, right? Protons, electrons have to do with the shape of the Earth because the Earth is made of protons and electrons, like everything else. So, like, in some sense, everything has to do with everything. Yes, you're correct.
See, I think that's a disambiguation as well. Like, I'm not saying everything has to do with everything. I'm saying that that's probably, you only need like two or three input forces to derive the amount of mass you need for things to become, asymptotically approach the shape of a sphere, right? Like, so we're not a perfect sphere. We're an oblate spheroid with higher harmonic, mass changes around the surface. Like that's why you get the geoid model.
Who's the
But
goofball talking? Is that Josh? Josh,
¿Qué
you don't know
pasa?
anything about math. You don't know anything about mass attracts mass. Please, don't give us a lesson.
I'm just letting you know.
All right, curvature of the Earth. Where is that measurement at?
So why is it that everybody knows how gravity works, but nobody can tell us how gravity works?
We understand the effects of gravity. We don't understand the causal function. That's where you get into like Higgs boson and why does mass have mass, right? We understand that there's certain materials, there's elements that are made up of different amounts of protons, neutrons, electrons, and then if you have a certain amount of those atoms, moles of an element or a compound, you multiply that by a constant, which is little g, and you can figure out what the acceleration of all of the other mass around it would be towards that control volume of mass. And because of that, we can figure out that because we understand these different elements and these different volumes and different densities, we can figure out we can normalize everything by those amounts and drive towards a little g constant. We don't know why it's that, but we know how to apply it to that. So it is a bit of a pragmatic fallacy. I agree.
One more time, avoiding the curvature of the Earth. Please, someone make another one.
That's the point of why Glovers come in here. We ask them, hey, you got the curve of the Earth? Gravity. Gravity makes things into balls. I say, no, gravity makes things flat. That's why your horizon's flat. Oh, yeah, no, that's refraction and gravity.
I was going to say, Yoder, I disagree with that because you can look at the other planets and you can derive their composition and understand their angular resolution
No, you
combined
cannot.
with their composition.
No, you
What?
can't.
Okay, so celestial spectroscopy is just out the window.
Yes, it's out the window. You can't look through air and decide that whatever's on the other side of all that air is something else.
I disagree with that assertion, but I'm glad you acknowledge the fact that you're throwing that out the window.
No, still not Earth curve measurements. Talking about everything but the thing that would actually prove the
He
shape.
wanted to talk about what planets are made of when you shine a flashlight at them.
Well, you're not shining a flashlight. It's a spectrum analyzer because when elements reflect light, or when things decay, or basically any spectral emissions, there's unique fingerprints that are one-to-one representations of the chemical compounds that it's composed of. We do it in the lab, right? It's accurate in a lab that has air in it.
In a lab is different. You don't have a bunch of air you're looking through.
Oh no, you can do it across the room in a lab, right? You do the experiment in high school chemistry where you lit some stuff on fire.
You can do it farther than 250 miles. Then do it 260 miles and tell me what you get.
Oh, you can do it over any distance if you have a sensitive enough sensor and you understand the atmospheric conditions that you have to zero out for. It's kind of like noise canceling headphones.
Okay. Now, you've done some spectroscopy on an object on the Earth that's 206 miles away. At what height were these two objects when they observed each other?
Oh, you can do radar ranging on any of the planets to understand how far away they are.
Yeah, I'm talking about this thing that was done here on Earth. All right, you've looked at an object using spectroscopy on the Earth that's 200 miles away. What height were these objects? The looker and the thing that's being looked at.
This is all hypothetical. I think you misconstrued that we were discussing an actual experiment at some point along this conversation.
Yeah, and I'm trying to identify whether it can be done on the Earth, and if it's done on the Earth at 200 miles, what is the amount of curve that's between those two objects, and was curve observed, period? Because if you're at 6 foot observer height and you see 200 fucking miles away, what the fuck's going on? It's definitely not a sphere with a radius of 3,959 miles. If you're at 3,000 feet, 200 miles is not functional. What the fuck's going on?
Yeah, assuming there's no medium around us, correct?
So we have to assume there's no medium, so we have to do it in a vacuum chamber. Who's got a 250-mile vacuum chamber I can borrow?
Or you could just, go to a high enough vacuum or high enough altitude where there is a vacuum naturally.
No such thing.
Disagree with that assertion as well.
It's not an assertion. You made the claim. Go ahead and prove it.
No, you just made a claim that there's no such thing.
Yeah, there's not.
Okay, then I'm telling you I'm
Glover, you're
disagreeing with
all
that
over the
assertion.
place. You're all over the place, Glover. Stick to a point.
No. Just trying to keep things civil and understand when you're saying you're making a claim that there is no such thing. I would love evidence of that.
Yeah, prove a negative.
I'd point you towards the standard atmosphere from 1976 that proves that the pressure density of the atmosphere using weather balloons asymptotically approaches zero.
So does absolute zero approaches zero. When do you hit it? At what point do you hit absolute zero?
It's not possible.
He said asymptotic, to be honest. He said asymptotically approaches zero, which means it never becomes zero, right? You know what an asymptotic
This is true.
function looks
Yeah,
like.
there's no such thing as
come
a
on,
perfect
guys.
vacuum.
You guys are breaking up. That's why I can't hear everything. I'm driving.
Okay, he said asymptotically approaches zero, which
Okay.
there's an echo, which means it's never zero, but very close to it.
How do you know it's not zero? And how do you know it's close to zero?
Well, I'll point you towards, once again, the external pressure sensor REL system that's on the outside of the ISS and has publicly published pressure sensor data.
They must have just put that out there recently, huh?
No, it's been published for a while. It's in my profile if you want to go read the paper.
No. Yeah, it sounds like they put that up there recently.
No, REL's been up there. I think it's since mid 2010s, early 2010s. I'll have to double check. But the primary author on the paper, if you're interested in reaching out to them, as well as the engineering unit, which you can go, test and verify that this thing works like they're claiming it works. I think it's at the University of Arizona in Phoenix.
I'm just going to go buy one and put it in my vacuum chamber and see if it works.
I'm just trying to provide you evidence.
I agree with you. I'm going to get your evidence, go buy one, put it in my vacuum chamber and see if it reads what my vacuum chamber reads.
Okay. But there's no such thing as a pure vacuum, and because of that, combining high altitude weather balloon data, you don't even have to believe in space to identify that the pressure gradient of our atmosphere as you go up in altitude asymptotically approaches zero. So there is a specific altitude where once again, Newton's second law, sigma F is equal to ma. There is an altitude where the pressure is low enough that the force of gravity even if you don't believe in gravity, right? You can see that there's a downward acceleration at 9.81 meters per second square. There's an altitude where those two cancel out and you have equilibrium.
What is this conversation about even? I'm so lost.
Yeah, not the curve of the Earth, that's for sure.
No, just gas
thing,
not needing a container.
Jesus, you're gonna unpack this now. My God, do you have a list of all the trigger topics and tangents that you want to go on, and you're just going down the list like click, click, click?
Yeah, pretty much.
Okay.
I believe the way we got there was someone was asking me if we could do long distance terrestrial observations without the medium, and they asked where we could get a vacuum chamber that is long enough to do these types of measurements. And I posited that there is a very large vacuum, just 100 kilometers up. So
Yeah, but
that's
they
how
were
we ended
very
up.
specific. They said terrestrial. They meant a person standing on the ground, observing another point on the surface of the Earth over impressive distances. Can we do that without the medium? The answer, Josh, is no,
No.
we cannot. Right. So, saying just no, we cannot would be a much better thing, moving the conversation forward, than nerding out on fucking density gradients.
I appreciate that. I do identify as a nerd.
Well, I also identify you as a nerd, so we have that in common.
Yoder just doesn't like Cavendish, it seems, in the comment section.
Why would you talk about Cavendish in 2025 when discussing mass attracts
Holy
mass?
shit, dude.
If you have gravimeters, if you have superconducting gravimeters that put Cavendish to shame.
Oh no, I agree. It's just the beginning. There's been a ton of technological advancements that you're able to get 5, 10 more significant figures on small g. But it's just it's the watershed paper, so it's the one I usually refer to.
Wow. Yeah, we've never heard that before,
Oh, I understand that.
It's like today, thanks to you, we've heard about Cavendish and Eratosthenes, I believe. Or was it the other guy? Sorry.
No. Yeah.
Right, okay. So those are foundational, for moments for our VC here. What else are you going to tell us?
I don't know. I just like to listen to the conversation and sort of provide my
How about
perspective
curvature?
as
Could you
needed.
tell us something about the curvature, maybe?
From a terrestrial point of view, I don't believe it's observable.
Oh, okay. Well, when I was a
Shit.
Cobra,
Or at least
That's a problem. So, from a terrestrial point of view, you don't think to see the curvature of the Earth? I really want to be clear, right? You're meaning from left to right, not away from you. Like the reason why the sun disappears
from
and
left
the
to right,
reason why
no.
we can't see that boat is because of the curvature of the Earth. That would be your claim. I just want to be clear which type of curvature you're talking about.
From a terrestrial point of view, I don't think that anybody in this conversation understands the properties of the medium well enough to definitively say what's causing these effects. Which is where we run into the interesting dynamics surrounding reliance solely on your 5 senses and direct observation of phenomena, as opposed to
What effects are you talking about, Josh? What effects are you talking about?
Oh, the effects of the medium. Looming, miraging, just light traveling through a medium.
How come on your globe Earth everything is flat?
I'm not saying everything is flat. I'm just saying that we don't understand the effects of the medium well enough to definitively have a conversation where we can convince the other party of anything.
We don't understand the medium that we shoot light through well enough to target things at distance. Like
whether or
the
not to
most
understand
accurate
where
targeting
the
systems are
optical location is the same as the actual location.
what the thing that we blow up with a targeting system. The most accurate targeting systems are lasers. You're saying we don't understand how light passes through the medium when we use it all the time to, these days, protect our borders and countries and early warning systems and blow that shit up, right? Directed energy weapons.
Do you know where the early warning systems are?
Do you understand what I'm talking about? You're saying that we don't understand the medium, but we use it all of the time. It's just a stupid claim, dude.
I disagree with that, but that's fine.
We
What, you
don't
disagree
understand the
that-
medium, Jedi, so we're not allowed to have airplanes anymore. Call the
Not allowed.
FAA.
Yeah, not allowed to use lasers anymore to target things at distance or to find range. Can't do that anymore.
You get the visual
Gonna have to tell the
feedback.
Royal
I'm just
Navy to
saying
put that
you don't
Dragon fire
understand it.
away.
You just don't understand it enough to claim that the actual position is the same as the optical position, right? So with
But
the
the
laser, you get the
targeting
feedback
system,
of the targeting.
the at the speed of light targeting system.
Oh yeah, at the speed of light,
at
correct.
the speed of light, blowing it up with a laser weapon. It's a targeting system, and it's also light.
Do you understand how a PID controller works? It's every single
No.
time step for the weapon system that you're guiding using a laser
Are
is
you
using
saying that it's not
the visual
accurate?
feedback.
Stop talking.
I'm saying it
Are
every
you
single
saying it's not
time.
accurate?
I'm saying it is accurate, but it's
Oh,
due
thank you.
to it's a differential control system. So it's at every second the sensor on the weapon is looking for the laser light, the feedback, and then it controls and points towards that place. And every single time step, it still does that at whatever time step the control system is tuned to. And as you get closer and closer to that object, the error due to the effects of the medium approaches zero. So it is accurate, but from that initial distance, the delta between where the laser actually is reflecting from and where it visually looks like it's reflecting from could have a decent amount of error.
Sounds like we understand the medium perfectly well.
Well, no, we just have a good control system that's able to eat through that error over time.
Target things
Oh,
over
guess it
distance.
sounds like we